Hello everyone, welcome you all for the chemistry class. Hope all of you are fine, doing well and great. Today we will be discussing about the hydrocarbon chapter. Last class we have discussed the GOC. I hope everything was clear to everyone, and I hope all of you have gone through the GOC chapters completely with the PPT that I have shared with you. And today we will be discussing the next chapter and the last chapter in the 11th class that we will be discussing in this crash course, that is hydrocarbon chapter. So if you are ready with everything, please put me some thumbs up or some reactions in the chat box so that I can start the class. Okay. Yes, guys, are you ready for the class? Shall we move? Shall we move for the class? Increase your volume. Okay. If my audio is not clear. Yeah. My audio is not proper to you. Supriya, or is it breaking, or like you want me to raise my volume? What about others? Is my audio is completely?
Raise your volume.
Sorry?
So raise your volume.
Raise my volume. Oh yeah. Good afternoon, Prathamesh. Raise my volume or raise my voice? This is microphone. This is the maximum that it can be.
And then your voice is clear only.
Clear, right?
Just take your website once.
Okay. So clear. Yeah. Okay. Yeah. So I think everything is clear and perfect. Okay, we'll be starting the hydrocarbon. Okay, we are going into the few important topics of the hydrocarbon. Yeah, the few important topics of hydrocarbons are alkane, preparation, properties and chemical preparation and physical and chemical properties of the alkane, and alkenes when it's coming to the alkene also. Alkene, alkane and alkene, the three things that we will be discussing in this preparation and properties of alkene, alkane and alkyne. And along with that we will be also discussing about the benzene also. Benzene. Yeah, benzene aromaticity, electrophilic aromatic substitution of benzene, which is a very important one, and the directive influence of the functional group, that is meta-directing and ortho-para-directing. All these things we will be discussing in the today's class. So this is just summary of what we are going to discuss in the today's class. Okay. Yeah. First one we are going to discuss about the preparation of alkenes. Yeah, first preparation of, all of you take your pen and paper and start writing or making notes here. Yeah, first preparation of alkene that we will be discussing is Sabatier-Sanderson reaction. It is a hydrogenation reaction. Sabatier-Sanderson reaction. Hydrogenation means what? It is nothing but addition of hydrogen molecule and adding dihydrogen to alkene or alkane in the presence of catalyst. Note down the reagent. What are the reagents that we will be using to do the hydrogenation reaction? That is H2 with nickel, platinum or palladium. I will be writing that over here. That is alkene on reacting with the H2 in presence of nickel, platinum or palladium. What I will be getting? Hydrogen will be adding. This hydrogen will be adding to both the carbon. And what I will be getting? I will be getting an alkane. And remember that what alkane I will be getting? I will be alkyl in which hydrogen will be added in the same side. Hydrogen will be added to the same side. That is important point. Here you will be getting a cis alkane, that is hydrogen will be added to the same side. Okay. And whenever you are using nickel, what is the point you should note down? You should use 523 to 573 Kelvin of temperature. That is the temperature that you should keep when you are using nickel catalyst. Okay. And for platinum and palladium, no need of higher temperature, it need only room temperature. So this is the point that you should note down. And just a minute. Okay, this is in the case of alkene. Now if I am taking alkyne, for alkane how many hydrogens we need? For alkane if I am adding, how many hydrogens we need? We need 2 H2 in presence of platinum or palladium. If I am doing, what I will be getting? Yeah, here there will be addition of 2 hydrogen. There will be addition of 2 H2 molecule if I am using alkyne. Okay, this is how we can prepare alkane using the hydrogenation method. Just note down all these points, and it's a very easy question only. Just add hydrogen between the 2 carbon of double bond. That's the only thing. Shall I move? Have you noted down all these points? Point note down is reagents and the temperature and what type of addition it is, syn addition. That is what the 3 points you should note down. Shall I move to the next method of preparation? Students? Yes. Okay. Next is from the alkyl halide. Alkyl halide, what is the method of preparation? This you might have studied it in haloalkanes and haloarenes chapter. What is that? Woods reaction. Woods reaction is particularly used for the preparation of symmetrical alkane. And remember the point that it is best for the even number of carbon. If I want to prepare alkane with even number, I will be preferring Woods reaction. Okay, how we can easily understand or easily write down the product? I will be taking 2 molecules of alkyl halide, and this will be treated with 2 Na molecule. What you have to do? Just remove 2 NaX. In presence of dry ether, and what is going to happen? This alkyl, one of the alkyl group will be forming 2 alkyl group will be forming free radical, and they will be combining together, and you will be getting alkane plus 2 NaX. Just remove the 2 Na and X and combine the 2 alkyl group by free radical process. Okay, that is how you have to do it. And remember that what is the limitation for this process? Methane cannot be prepared. By using this method. What is the reason why methane? Because we will be taking always 2 molecules of alkyl halide for preparing alkane using the Woods reaction. But methane, there is only 1 carbon, so methane can't be prepared. Okay, and another limitation is it can't prepare odd number of. It's not like it can't prepare, won't prefer for the preparation of odd number carbon alkane. Why it is not preferred? Anybody have any idea why it is not preferred? Why it is not preferred? I can prepare. How I will be preparing? If I want to prepare alkane with odd number of carbon atom, how I will be preparing is, I will be taking, just imagine that I am taking CH3X. I will be taking 2 different alkyl halide. In the previous case, for symmetrical alkane, I have taken same alkyl halide. Here I will be taking 2 different alkyl halide, CH2X. Okay, I have taken 2 different alkyl halide. This will be treating with 2 Na in presence of dry ether. What I will be getting? What are the different products I will be getting? For that, you should know what are the different free radicals that is forming here. Here, one of the free radical forming is CH3. Another free radical forming is CH3, CH2. Okay. Now, what are the different products you can see here? First product is this free radical will combine with CH3, CH2 free radical, and you will be getting alkane with odd number. You will be getting alkane with odd number of carbon atom. And what are the other products? This is not only the product forming here. This is not only the product that is forming here. What are the other products? Here, this free radical will again combine with itself and will be forming ethane, CH3, CH3. And also this free radical will combine again with itself and will be forming another, will be getting butane, CH3, CH2, CH2, CH3. That is here, if you observe what you can see, you got a mixture of product. And because of the formation of mixture of product, separation of this alkane with the odd number is very difficult. The separation is difficult. Due to that only we are not preferring preparation of odd number of carbon alkane by using Woods reaction. Difficult to prepare, difficult to separate. Yes. Hope all of you understood this one. What are the points that you should note down for Woods reaction? Is it clear? Can I move to the next? Everyone? Yes. Just note down the points that I am writing on the board. PPT will be shared with you. Yes. Okay. Next method of preparation. First one is preparation from the alkyl halide. That is very easy only. Alkyl halide on reacting with the hydrogen H2 in presence of zinc and HCl, or magnesium in presence of water, or lithium aluminum hydride. These are the 3 reagents you should keep in your mind. How I can prepare alkane from alkyl alkyl halide by using hydrogenation. These are the three reagents that you will be using for it. And how you can write the product? Writing the product is very easy. Remove the halogen and add hydrogen. Remove the halogen and add hydrogen. That is the only point you should note down. Okay. Remove the halogen and add the hydrogen. Okay. That is what reduction of alkyl halide. Now look at here another one, Franklin reaction. Franklin reaction, if you observe, it is very similar to the Woods reaction. It's very similar to the Woods reaction. Now what is the difference we can see? In the Woods reaction we are using sodium metal, but in the case of Franklin reaction what you can see? You can see zinc metal. That is the difference. Using this difference you should understand that what type of reaction it is. Okay. Is it clear? Just note on this point only. There is not much thing you should know about it. Okay. Yes. Are you done with this? Take a note of it. I don't want to go much into it. Yes. Who is this? Okay. Guys, is everything fine? My audio, video, everything is fine? Going well? Hello? Oh, yes. So guys, have you noted down this Franklin reaction and Woods reaction? Okay. Anything, any problem is there in audio, video or anything, or have you finished this? Okay, everything is fine, right? Have you finished this one? Just note on the point, Franklin reaction and Woods reaction are the two reactions we discussed, and in that the difference is only the metal that we are using. For Woods reaction the metal we are using is zinc, for Franklin the metal we are using is zinc. That is only the difference. And reduction using alkyl halide, note down these reagents. That's the only thing. Hydrogenation, removing halogen and adding hydrogen. That's the difference. Shall I move, students? Move to the next. Okay. Yes. Now next one is a preparation from carboxylic acid. How I can prepare it from the carboxylic acid? That's the next method of preparation. Yes. Yeah. First method is decarboxylation. I hope all of you have know about this decarboxylation process, because in some of the paper discussion we have discussed this one. Yeah. What are the main points you should discuss? You should note down. It is heating sodium salt of fatty acid. Sodium salt of fatty acid, that is RCOONA. RCONA, I am heating it with soda, sodium hydroxide and calcium oxide. And note down that what is the ratio of calcium hydroxide that we are taking here. Sorry, calcium oxide and sodium hydroxide that we are taking. It is 3:1 ratio. This also can, this type of question also you can expect from the exam. 3:1 ratio. Okay. And what are the product that you can see here? You can see the product here is, here 2 molecules of sodium salt of alkyl halide will be alkyl, sodium salt of alkyl will be there, and in that the alkyl group will be the 2 alkyl group which will be combining by using the free radical reaction, and we will be getting, you will be getting an alkane. And what is happening to the COO? Here there will be elimination of CO2. There will be elimination of CO2, and also one more product you can see, that is what is that? Here this will be taking place in presence of water also. This is taking place in presence of, yeah. And one more product what you can see, that is hydrogen. Hydrogen that is eliminated will be forming here. These are the products that you can see for decarboxylation process. And note down, yeah, sorry, it's not that one. The product that you can see here, it is COONA. Okay, how you can write the product very easily? Just remove this one, COONA plus NaO, which means I will be getting Na2CO3. That's the product that you can see here. Okay. Is it clear, everyone? Just note down the product that is forming here. 2 molecules of RCONA will be combining and will be forming RR, and we will be getting. And note down that point. This is the best method for the preparation of preparation of methane. Best method for the preparation of methane, which already we have discussed in some of the mock test. Okay. And note down what is the use of CaO here. CaO is used to keep NaOH. CaO is used to keep the NaOH. Okay, sorry, this is not RR, it's RH. To keep the NaOH dry. and it is hygroscopic. What is meant by hygroscopic? Hygroscopic means absorbing water. COA will be absorbing water from the NaOH and making it dry. Okay. Yes, this is the point that we should note down for carboxylic acid. How we can prepare alkane from carboxylic acid. Okay. Is it clear? Just note down the point. Everything I have mentioned in the slide. Just noting down the point and just by hearting. That is the main thing here. Okay. Next is Cope's electrolytic method. This is another method for the preparation of alkane. Okay. Yeah. Note down the point. Electrolysis of aqueous sodium or potassium salt of carboxylic acid. This is nothing but electrolysis of RCOONA, aqueous solution. Electrolysis of RCOONA in presence of what? Yeah, aqueous solution of in presence of H2O, in presence of water. And during the electrolysis, what are the product we are getting? Here actually the R will be combining together through the free radical, and you will be getting R, and another product that you will be getting is CO2. The CO2 group will be eliminating here, and you will be getting CO2, and also the two water molecule. Here there are two water molecule we are using. One is H plus OH minus, H plus OH minus. Okay. Here hydrogen will be combining and will be forming H2, and the remaining OH will be combining with the sodium and will be forming 2NaOH. Okay. Hydrogen will be combining and will be releasing H2 gas, and CO2 will be removing, that is CO2, and the two alkyl group will be combining by free radical mechanism and they will be forming alkane. Okay. And the point that you have to note down is, here this method is taking place as it is an electrolytic method. It is taking place in anode and cathode electrode. And in anode, what are the products that you are obtaining? In anode you can see these are the products, alkane and CO2. These are the product that is obtaining at anode, and the product that is releasing in the cathode, that is H2 gas. That is the point that you have to note down here. Question can ask, in the Cope's electrolytic method, the product that is obtained in the anode reaction, what are the products, and what are the product that is obtained in the cathode reaction. So these points can help you to solve those type of questions. Okay. Shall I move, students? Are you clear with these points? Shall I move? Yes, I think I can move. Or do you want time to note down the point? Do you want time to note down? No, right? Yes. Okay. These are the major preparation of alkane. Now we can go into the properties of alkane. Okay. Yes. The first property I want everyone to take a note of is halogenation reaction. Halogenation reaction. This is also a reaction you have studied it in haloalkanes and haloarenes chapter. Okay. In the halogenation reaction, what is happening? In the halogenation reaction, alkane group is an alkane group. Okay. Suppose R. Okay. An alkane group is halogenating in presence of what? Cl2, in presence of UV light. And on halogenating, what I will be getting? I will be getting RCl. That is, his hydrogen will be replaced by halogen. That is what the product that is obtaining here in the halogenation reaction. And plus HCl. Okay. That is, this hydrogen will be replaced by the chlorine here, and that hydrogen will be combining with the next chlorine and will be forming HCl. This is a summary of this reaction. Okay. Now note down the point. Among the halogen, which halogen will be showing highest reactivity and which will be showing lowest reactivity? The reactivity order of halogen is F2Cl2 Br2I2. What is the reactivity order? F2 is greater than, Cl2 greater than, Br2 greater than I2. And remember that among all these, only Cl2 and Br2 only will react. Only Cl2 and Br2 only will react. Why fluorine and iodine is not going to react? What is the reason? Anybody have any idea? Why fluorine is not reacting? Because fluorine is highly reactive. It is highly reactive and it won't be giving the product properly. And why iodine is not undergoing this reaction? In the case of iodine, what is the product you can expect here? If I am putting iodine here, I2 here, what is the product you can see? Ri plus, what is another product you will be getting here? HI. And what is the property of this HI? HI is a highly reducing agent, right? Highly reducing agent. It will be reducing the reaction back. So we won't be using iodine here. But we can also use iodine if I am using a strong oxidizing agent. That is, if I am using HiO3 or HNO3 to remove the HI, then iodination is possible, or else iodination is not possible. Okay. Now among this chlorine and Br2, there are two properties that you should know about chlorine and Br2. Here chlorine is more reactive. Chlorine is more reactive and less selective. And what about bromine? Bromine is more selective and less reactive. And the reactivity order, if you observe, the reactivity order is for primary, secondary and tertiary. For primary it is 1:3.2:5.2. Yeah, the rate of reactivity, rate of reactivity, if I am observing for the primary, okay, this for primary I am writing Rp is to Rs is to Rt. That is rate of the halogenation reaction for primary, secondary and tertiary. It is 1:3.2 is to 5.2. That is what is coming. And in the case of bromine, how the rate of primary is to rate of secondary is to rate of tertiary, how it will be coming? It is 1:86:1600. This is the rate you can see. So among these you can see, as the rate is 1:86:1600, which is higher, you can see for bromine it will be always attaching or always adding to tertiary, then secondary, then primary. That is in the case of bromine. Bromine, always the addition will be taking place on the tertiary carbon hydrogen, and then secondary, then primary. But what about chlorine? In the case of chlorine, as there is a difference is very less, how you will be finding it? By taking the product of NP, NP-Rp. What is NP? NP is the number of hydrogen in the primary carbon, and NS-RS, NT-RT. That is, NP is the number of hydrogen in the primary carbon, NS is the number of hydrogen in the secondary carbon, ND is the number of hydrogen in the tertiary carbon. Higher value of this product will tell about the substitution. Among these, which is having the highest value, that will be tell about the substitution. Which one is going to substitute. Okay, I will give you an example. I hope already you know about this through the haloalkanes chapter itself. I am just giving an example. CH3, CH2, CH3, Cl2 in presence of H nu. What are the product that you can expect for this one? What will be the product? What it is Cl. As it is Cl2, it is more reactive and less selective. So you have to take the ratio of this one, NP, Rp, NS, Rs and NT, Rt. Okay, from here you can see this is the secondary and these are the primary, where you will be getting the major product. First of all, I will be getting two products here. If I am replacing the primary hydrogen with a chlorine, what is the product you are getting? CH3, CH2, CH2, Cl. This is the one of the product that I can expect. That is replacing primary hydrogen with the chlorine. And what is another one? There is another carbon, right? Or there is another hydrogen here, that is secondary. That is CH3, CH, CHCl, CH2, CH3. My question is, among these, which is the major product? First one or second one? First one or second one? Which is the major product? Who is going to tell me the answer? Second one is? Yes, very good. Second one is a major one. Why it is major one? This is minor one. Why it is a major one? Because how I will be checking? Yeah, how I will be checking the major one or minor one? Take the ratio, take the product of NP-RP. Here how many? What is the NP-RP value? NP-RP value for this compound. NP is number of primary hydrogen. How many primary hydrogens are there? 6 primary hydrogen. And rate of primary for chlorine, what it is? It is 1. So 6 into 1, it is 6. Now NS is the number of hydrogen in the secondary carbon. That is how many? 2 into RS, rate of secondary. What is the rate of secondary? 3.2 is coming. I think 3.2. Yeah, 3.2 something. What is the answer? What is the product you are getting? What is the value you are getting? Is it 3.2 or something? I think it's not 3.2, it is 3.8. Okay, just correct it. It is 3.8. It is 3.8. Okay, on solving this, what you will be getting? You will be getting an answer around 7.6 something, right? So among these, which is the highest value? NSRS is the highest value, which means the chlorine which is substituted in the secondary carbon is the major one. Which means the chlorine which is substituted in the secondary carbon, it is the major one. Okay, this is one of the important question will be asking from the NEET. Don't make any mistake which is a major one and which is minor one. Just go through the NP-RP or NSRS or NT-RT product and check which is higher value. That is going to be our answer. And in the case of bromine, if it is bromine, no need to think about anything. Bromine will be adding to tertiary carbon first, and if there is no tertiary carbon or if there is no tertiary hydrogen, it will go to the secondary hydrogen and then primary. That is the only thing you should note down. Is it clear, students? Can we go to the next? Any doubt anybody is having?
NP-RP, please explain again.
NP-RP. NP is what?
Yeah.
NP is number of hydrogens in the primary carbon. How many hydrogens are there in primary carbon? This is the primary carbon. 3 hydrogens are there. And this is also primary carbon and 3 hydrogens are there. So NP is 6. And what is RP? RP is the rate of the primary, that is 1. That is 1. So 6 into 1, it is equal to 6. And for NSRS, it is 2. Secondary carbon, we can see only 2 hydrogens. And 2 into rate of secondary, that is 3.8. We will be getting 7.6. So higher value is for the secondary. So chlorine which is substituted on the secondary carbon will be the major one. Got it? Am I cleared your doubt?
Yes, sir.
Okay. So if you don't have any doubt, we can move. Shall we move to the next part, students? Yes, guys, are you there? Everyone? Or you want time to take a note of it? Because this is a common thing in haloalkanes chapter and hydrocarbon chapter. So take a note of it. It's a very important one. Okay, next is about the isomerization and aromatization. Okay. Another property of alkane, that is N-alkane. N-alkane can be converted into branched isomer using anhydrous AlCl3 or HCl. Anhydrous AlCl3 or HCl. Example, N-butane. If I am taking N-butane, 1, 2, 3, 4. N-butane. If I am treating N-butane with the AlCl3 and HCl, what I will be getting? I will be getting isobutane. This is the product that I will be getting here. Okay. Suppose if I am taking N-pentane. N-pentane, what is the product I will be getting? AlCl3 or HCl. I will be getting a branched isomer. That's only the thing. Alkane will be converting into branched. So this N-pentane, how I can convert it into branched one? I can make a, first of all I can make an isopentane and isobutane. Isopentane. So 1, 2, 3, 4, 5. Isobutane, and also I can make a neopentane also. How I can make a neopentane? Okay, hereby I can make a neopentane also. Okay, that is carbon H3. So this is one of the application or one of the properties of alkane, that is isomerization. N-alkane can be converted into isobutane or the neo or the branched isomer of it by using anhydrous Al, Cl3 or HCl. Okay, yes. Just convert the alkane into branched one. That's only the thing. That's only the product you should note down here. Shall I move next? Next property. Yes. Next property is aromatization. This is another important one. Question has been asked in the previous year. Alkane with 6 or more carbon. Alkane with 6 or more carbon when heated with oxides of vanadium, chromium or molybdenum at 773 Kelvin, which results in benzene and its derivative. Another important one. It is used for the preparation of benzene or its derivative. That is, if I am taking an N-hexane, this is cyclohexane. Okay, no, not cyclohexane, N-hexane, normal hexane. 1, 2, 3, 4, 5, 6. 5, 6. N-hexane on treating with Cr2O3 or delta. What I will be getting? They will be involved in a cyclization process which will lead to an aromatic compound. That is, I will be getting a benzene over here. I will be getting benzene. Not only CrO2, I can also use MO2 O3 also. MO2 O3 in presence of heat. Okay. One of the previous year question I have seen is N-hexane. N-hexane, it is treated with MO2 O3 in presence of heat. What is the product? It is benzene only. Now instead of hexane, if I am using heptane, what is the product we will be getting? One thing you have to fix is you have to fix the aromatic compound. You have to fix the benzene. And what is the extra carbon that is coming here? That you will be putting as a substitution. This is CH3. That you will be putting as a substitution here. Extra carbon you will be putting here as a substitution. Okay. Now instead of this, if I am just putting, or if I am finding out for N-octane, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. What will be the product? What are the products that you can expect here? Yes, sorry. Methyl benzene. Here it is, X is there. 8 carbon is there. So methyl benzene only will get. How we can get methyl benzene? Methyl benzene means toluene only, right? Ethyl benzene. Very good. Are we going to get only ethyl benzene? Yes. First of all, we have to fix the aromaticity. Then how many extra carbons are there? This is octane. 2 extra carbons are there. That will be forming a side chain. And this is not only the product that you will be getting. What are the other possibility we are having? I can make one CH3 here and I can make another one here. That is ortho one. And also what I can do? One is CH3 here and I can make a meta also. And I can make a para also. So these are different products that you can see if I am treating N-octane with a MO2O3. That one thing that you have to fix is you have to fix the aromatic compound or aromatic ring, and the remaining what? Remaining you have to put as the side chain. That's the point. Is it clear, everyone? Are you done? Yes, this is all about alkane. Alkane we have completed the properties and preparations. Make a note, this is only the important point you have to note down for the alkane. Remaining are not that much asked in the exams. So these points you have to note it. You have to make a proper note of it. Okay. Yes, moving. Next is preparation of alkene. The first method of preparation of alkene, that is by using our hero. I think this is one you have seen a lot of time in your exams. Preparation of alkene from alkyne, that is by the partial reduction. And first method of preparation is by using Lindlar catalyst. Lindlar catalyst is the catalyst that you are note down. It is equal to H2 bar PD over BSO4. If hydrogen is treated with alkyne, this is my alkane in presence of Lindlar catalyst, that is H2 bar PD BaSO4. BaSO4 is actually it is used as a poison. It is having a poison effect, and also it is actually the main duty of BaSO4 is providing a support to the catalyst, solid support to the catalyst, and this reaction should take place in presence of sulfur or quinoline. What is sulfur or quinoline? They are poison. Poison. What is the need of this poison? That I will be telling you now. What I will be doing? Just hydrogenation. I will be breaking this triple bond and I will be adding a hydrogen. Remember that whenever you are adding hydrogen, it should be syn addition. That is, hydrogen should be added on the same position. Yes. This is the product that you are getting, that is alkene. Okay. Now what I want to do? I want to stop the reaction till here. I want to stop the reaction till here. If I am not using the sulfur quinoline or the poison, these are the poison, the reaction will continue till the formation of alkane. I want alkene only, so I will be stopping the reaction till here by using a poison. Okay, this is the point that you have noted down here, and the addition will be syn addition. Hydrogen will be in the same position. That is a stereochemistry. You should note down. Is it done? Is it done? Shall I move?
If sulfur and quinoline is not used, then
if sulfur and quinoline is not used, which means the reaction will continue till the formation of alkane. Till the formation of alkane. Poison means it is going to stop the reaction to a particular point. Got it? Yes. Next one is Briggs reduction. Briggs reduction also same thing only. What is the difference between Briggs reduction and the reagent and the linear catalyst reaction that we discussed is, in the case of Briggs reduction, we are using sodium or lithium in liquid NH3. Sodium or lithium in liquid NH3. That is, I will be taking an alkene. I will be taking an alkene here. Okay. Now this alkene, if I am treating it with a sodium in liquid NH3. Sodium in liquid NH3. What is the product we are getting here? Here what is the product we are getting is, we will be getting a trans alkene. Here hydrogen will be adding, but addition of hydrogen is in the trans position. That's only the difference you can see here. This is also a hydrogenation reaction. Okay, I will be writing plus H2 in presence of sodium in liquid NH3. This is also a hydrogenation reaction, but addition of hydrogen is in the trans position. Okay, that is a point you have to note down. Trans alkene. In the question they will be giving trans alkene, cis alkene. But if you see this reagent, you should mark what is answer. It should be trans alkene. Okay, that is a point you have to note down here. Yes, are you got it? And note down the point, does not work on terminal alkane. Okay, terminal alkane won't work with the, okay, okay. Terminal alkane won't be working with the sodium in liquid NH3. What is going to happen? They will be forming a salt. Because of the terminal free hydrogen. Okay. Yeah, shall I move? Have you noted down the point? Briggs reduction and the hydrogenation by using linear catalyst. The difference is the stereochemistry. One is 6-alkene, second one is trans alkene. Yes. Don't forget these reactions. Have you noted down, everyone? Take a screenshot, or just whatever I am writing, just write it along with me, so that it will be helping you. Okay. Now next one is dehydrohalogenation. This you already have studied in haloalkanes and haloarenes chapter. How we can prepare alkene by using dehydrohalogenation. Dehydrohalogen means removal of hydrogen and halogen by using which reagent? Alcoholic KOH. If I am treating alkyl halide, just I am going to treat alkyl halide, or okay, just CH3 CH3. Okay, this is CH2 okay, this is CH3 okay, CHX. This is my alkyl halide, and this I am treating with alcoholic KOH. What is going to be the product here? And what is this reaction? This you have studied in haloalkanes chapter. It is elimination reaction or E2 elimination. In the E2 elimination, what you have? What is the product you got? You got the product alkene. Okay. Now remember that E2 elimination, it follows Seitz-Zaff rule. It will be always follow Seitz-Zaff rule. What is Seitz-Zaff rule? That I can tell it by mentioning the product here. Okay. What are the products that you can see here? It is an E2 elimination. E2 elimination means it is alpha beta elimination. This is the alpha carbon. This is the alpha carbon, and this is the beta position, beta carbon. These are the beta position, beta carbon. So what is going to eliminate? Halogen from the alpha position and hydrogen from the beta position is going to eliminate, and we are going to get the product by putting a double bond here. So first product that I will be getting is CH3 CH double bond CH CH3. If I am removing hydrogen from this carbon and hydrogen from the halogen from the third carbon, I will be getting first product. And what is second product? If I remove halogen from the third carbon and hydrogen from the fourth carbon, what is the product? CH3 CH CH double bond CH2. This is the product, and one will be major and another one will be minor. Which one is major? Which is minor? Which is going to be major? Yes, very good. First one is major.
Minor.
Yeah, very good. First one is major and second one is minor. And this major product we will be calling it as Seitz-Zaff product. Seitz-Zaff product, and the minor product we will be calling it as Hofmann product. Very good. Why this is major? More number of alpha hydrogen. More number of. In the yesterday's GOC chapter we have discussed that more the alpha hydrogen of alkene, more will be the stability. So here you can see more alpha hydrogens are there, right? More alpha hydrogen. How many alpha hydrogen? 6 alpha hydrogens are there. But in the case of second one, the minor product, you can see only 1 alpha hydrogen. Okay, so that is the point you have to note down here in this one. Yes. Another point you should note down is about the reactivity of halide. Reactivity of halide. Among this, which halide can give higher rate? That is alkyl iodide, then alkyl bromide, then alkyl chloride. This is how the reactivity will be following. Okay. And instead of alcoholic KOH, remember that instead of alcoholic KOH, if you see aqueous KOH in the reagent side, don't get confused. That is not going to be E2 elimination. What is going to be that? That is substitution reaction. That is substitution, in which you will be getting alcohol as the product. Okay, that is the difference between substitution and elimination reaction, especially in the case of E2. If I am using an aqueous solution, which is protic solvent, right? For protic solvent, it will lead to the substitution, and for alcoholic KOH, it will be giving the elimination. So note down all these points. Don't forget, this is a common thing in haloalkanes chapter and hydrocarbon part. Shall I move, students? Are you done? Take a note of it. If you are done, just put a thumbs up so that I can move. Take a note of each and everything. It's a very important one. Yes. Everyone.
So what is Seitz-Zaff rule?
What is?
Seitz-Zaff rule.
Seitz-Zaff rule is nothing but more substituted alkene is stable one, and less substituted alkene is the least stable one. That is what Seitz-Zaff rule. More substituted, here this alkene is more substituted, right? That is CH3, or more alkene with more number of hydrogen atom, that is the major product. And that rule which is saying that alkene with more alpha hydrogen is the major one is Seitz-Zaff rule. Got it? Or we will be calling the product is Seitz-Zaff product. Okay, thank you. Okay, next is dehydration of alcohol. Next method of preparation of alkene is by using dehydration method. Dehydration also we have discussed. How? What is happening here in the case of dehydration? In the case of dehydration, what is happening?
Removal of water.
Removal of water. Very good. Removal of water. That is, what are the reagent we will be using is, we will be using a strong acids, H2SO4 or H3PO4 for this one. And remember that one point we should note down is, here there will be a formation of carbocation here. In the case of removal of water, there will be formation of carbocation. Example, I can take RCH CH CH3 OH. This is a alcohol, and this alcohol on treating with water H+, what is going to happen? This lone pair will be attacking on this H plus, and there will be removal of water, which will lead to the formation of a carbocation CH plus CH3. I got a carbocation. And remember that whenever you got a carbocation, you should check whether rearrangement is possible or not. Check for rearrangement. Here it is in the secondary, it is secondary carbocation. As it is secondary carbocation, and on rearranging there is no possibility to convert it to tertiary. So this will be the carbocation, stable carbocation here. Now once it reacts with H plus, what is remaining? OH minus is remaining, and this OH minus will be attacking on this carbocation. Sorry. No. Okay, once we got this carbocation, what is the next step? This is alpha position. There will be beta elimination. Hydrogen from the beta part will be eliminating. Here you can see this is the beta and this is the beta. Which beta hydrogen will be eliminating? Which beta hydrogen will be eliminating? Alpha side or beta side? Which beta hydrogen will be eliminating? First beta or second beta? First one, very good. First one only will be getting a more stable alkene, CH3. Okay, now you can see here one hydrogen from here will be eliminating, and which will result to the carbanion, and that will make a bond with the carbocation, and you will be getting alkene here. So this is what the formation of alkene by the dehydration of alcohol. Take a note of it. Remember that you should always check for the carbocation rearrangement. Okay, and this will be also following the Zaitsev rule only. More substituted alkene will be the stable one. And if I am removing this beta carbon, if I am removing this beta hydrogen, I will be getting a less substituted alkene, which is not going to be the major one. Okay. Yes. So this is the point regarding dehydration of alcohol and the preparation of alkene. Is it done, students? Take a note of it. And reactivity order will be based on the stability of carbocation. Tertiary alcohol can give tertiary carbocation. So that will be more stable comparing to secondary than primary. Okay. All the points, everything I have mentioned, just you have to study. That's only the thing you have to do. Just remember how the things are going. Okay. Shall I move to the next? Dehydration. So next we will be moving to the dehalogenation of vicinal dihalide. Okay, another method of preparation of alkene is by using dehalogenation of vicinal dihalide. Dehalogenation means what? I am removing halogen. Now down, vicinal dihalides have halogens on the adjacent carbon. This is a vicinal dihalide. Here you can see halogen which are on the adjacent carbon, CH2X. Okay, and how I can remove this halogens and how I can make it into a alkene? How I can do that? If I am using zinc dust in alcohol, zinc dust in methanol, especially methanol, CH3OH, under temperature, what I will be getting? This halogen will be removed, that is CH2X. What you have to do? 17% of CH3OH. Just remove this one, just remove this halogen and put a double bond over here. That's the only thing you have to do. CH2 double bond CH2, and the zinc will be combining with the two halogen, and you will be getting ZnX2. That's the only thing you have to note down here. Okay. And not only this for vicinal dihalide, it can be also used for geminal dihalide also. What is meant by geminal dihalide? Geminal dihalide means, what is meant by geminal dihalide? Geminal dihalide, yeah, in the single carbon you can see two halogen. In the single carbon you can see two halogen. So that is what geminal dihalide. It can also form an alkene, but usually requires strong conditions. Only thing is that for geminal dihalide you need strong conditions. That is the only difference. Okay. Done everyone? Shall I move? Have you taken the note? Yes. Is it clear everyone? Just remove the halogen and just add hydrogen over it. Okay, I am moving. Okay. Next is properties of alkene. What are the different properties of alkene? First one is electrophilic addition reaction. Electrophilic addition reaction is all about Markov-Nikov rule. Markov-Nikov rule, you know that. What is Markov-Nikov rule? Okay. Consider an alkene. What is Markov-Nikov rule? According to Markov-Nikov rule, hydrogen, if I am adding a hydrogen halide, hydrogen will be added to that carbon where there is more number of hydrogen. Hydrogen will be adding to that carbon where there is more number of hydrogen, and hydrogen will be adding to that carbon where there is lesser number of hydrogen. So the product that we are getting here, you can see R C HX CH3. This is one of the property in which you will be getting alkyl halide. Okay. Now note the point you have noted down is you should not blindly believe the Markov-Nikov rule. You should not blindly believe the Markov-Nikov rule. Why? Why I am saying it? Because you should check for the carbocation rearrangement also. That is how it will be happening is, first of all, this double bond will be shifting to that carbon in which it can form a stable carbocation. Here the bond will be shifting towards the terminal carbon, and which results in the formation of RCH plus CH2 minus, and into this minus the hydrogen will be adding. Hydrogen will be adding into this minus, so I will be getting RCH plus CH3. Now here you got a carbocation, right? Here you got a carbocation. You should check for carbocation rearrangement. Check for carbocation. Check for carbocation rearrangement. After that only you have to add the halogen. After that only you have to add the halogen. If this alkyl group is a tertiary alkyl, definitely the carbocation will shift to that tertiary carbon, and in that tertiary carbon only this halogen will be adding. So here it is secondary, so there is no rearrangement possible. So the product is CHX CH3. Got it, everyone? Always you have to check for carbocation rearrangement. Don't blindly follow the Markov-Nikov rule all the time. Okay. And hydrogen will be always added to that carbon where there is more number of hydrogen. Yes. Is it done? Shall I move? Shall I move, students? Yes. Okay. Thank you for your response. Next one is addition of halogen, addition of X2, or halogenation reaction we will be calling it as. Okay, halogenation reaction. What I will be doing is I will be adding halogen to an alkene. Example, what I will be doing is I will be taking Br2. And Br2 it will be doing in presence of CCl4, or CHCl2, or it can be used in any non-polar solvent. Okay, now how it is happening? First of all, what the bromine will be doing is, this pair of electron will be attacking on the bromine, and there will be shifting of the bond, and as a result we will be getting a cyclic halonium ion. We will be getting a cyclic Br plus halonium ion. Okay, and another bromine will be here, which is having negative charge, and that will be attacking on this carbon, and which will be leading to the formation of dihalide or vicinal halide. So Br. Now here you can see the bromine is added in the anti position. So that is what you have noted down. It is an anti-addition. In the case of addition of halogen, which is occurs by a cyclic halonium ion. This is what cyclic halonium ion. This is cyclic halonium ion, and we will be getting an anti-product. And it is also used for the test for unsaturation. Beginning, the bromine will be having a reddish brown color, and once this reaction has completed, that reddish brown will be changed to a colorless. So it can be also used for test for unsaturation. Okay. Shall I move, students? Are you done? Shall I move? Yes. Everyone noted down the things? Okay. Okay, next is anti-Markov-Nikov rule. Anti-Markov-Nikov rule is very important. And why it is very important? Because there is no exceptions here. Exceptions here means there is no carbocation rearrangement here. That is, here we will be using only HBr. Note down that anti-Markov-Nikov rule is applicable only to hydrogen bromide. It is applicable only to hydrogen bromide due to some thermodynamic reasons, and it is taking place in presence of organic peroxide. In presence of a peroxide, if HBr is treated with alkene, what is going to happen? The bromine will be attaching to that carbon where there is more number of hydrogen. In the case of Markov-Nikov rule, we have discussed that halogen will be attaching to that carbon where there is less number of hydrogen. But in the case of anti-Markov-Nikov rule, it is just opposite to the Markov-Nikov. That is, bromine will be attaching to that carbon where there is more number of hydrogen, and it is happening through free radical addition mechanism. Okay, and it will be observed only in HBr. That's the point we should note down. Does not work on HCl or HI due to thermodynamic reason. That is the bond enthalpy. Okay, this is the point you have note down. Yeah. That is, if I am just taking a alkene CH double bond CH2 HBr, where the bromine will be substituting and where the hydrogen will be substituting. Bromine will be substituting to that carbon where there is more number of hydrogen. So R CH2 CH2Br. This is going to be the product. Okay. Done everyone? Shall I move? Anti-Markov-Nikov rule. It's a very important one. Don't lose any mark in this one. Yes. Next one is oxidation. Oxidation using Bayes reagent. What is Bayes reagent? Bayes reagent is cold dilute alkaline KMnO4. Cold dilute alkaline KMnO4. It will lead to the formation of vicinal glycol. Vicinal glycol, in which syn addition of 2 OH group will be taking place. How we can understand the reaction? There is a double bond. Yes, in presence of cold alkaline KMnO4, cold alkaline KMnO4, what is going to happen? How to write the product? Just what you have to do, break this bond and add OH to both the side. Break this bond, add OH to both the side. That's only you have to do here. And on doing this, what is the product you are getting here? You will be getting an OH which is added in the same position. OH should be added in the same position, that is syn addition. We will be getting a vicinal glycol. This is glycol, 2 halogens on the adjacent carbon. Okay, that's the point. And this reaction will take place only if KMnO4 is taken place in cold dilute or alkaline cold dilute or alkaline solution. And if I am using a hot acidic KMnO4, what is the product you will be getting? Instead of this, if I am using a hot okay, let's suppose I am taking a yes, hot acidic KMnO4. What is the product you will be getting? How to write the product is just break this bond, put oxygen between these two. Break this bond, put oxygen between these two, and what is the product you are getting? Just look at that. Double bond OH. You are getting an aldehyde here plus you will be getting a ketone. Okay, and the aldehyde that formed here, this will again undergo oxidation and it will be converting into a acid. That is, this is a methyl group, so CH3 C double bond OH plus the ketone. That is the product you will be getting here. Okay, clear everyone? If it is dilute alkaline KMnO4, the product you will be getting is a vicinal diol, and if it is a hot acidic KMnO4, the product that you will be getting is an acid and ketone. That is, just add oxygen between the two double bonded carbon, and what are the product you are getting is, if it is aldehyde, then oxidize it again and give the product, and ketone will be staying like that. Okay, Shall I move, students? Done? Yes, thank you. Next one is ozonolysis reaction. Ozonolysis reaction, I have discussed it while preparing or while discussing the paper, mock test paper. You can easily write down the ozonolysis product. How? What is the trick that I have mentioned in that class? That is, first of all, in the case of ozonolysis reaction, it will be reacting with O3 in presence of CCl4. In presence of CCl4, what I will be getting? I will be getting an ozonide. I will be getting an ozonide, and this ozonide can undergo either reductive ozonolysis by using zinc water, or it can undergo zinc water. It can undergo oxidative ozonolysis. Oxidative ozonolysis can take place in presence of H2O2 or Ag2O. What is the product? How we can write the product? Just break this double bond and put oxygen. Break the double bond and put the oxygen. Okay, let's suppose this is a hydrogen, this is an aldehyde. Yeah, what is the product you are getting? CH3 C double bond OH. You will be getting a ethanaldehyde plus you will be getting a ketone here. Okay, now this is the product of reductive ozonolysis. This is the product of reductive ozonolysis. How I can make the product of oxidative ozonolysis? What we have to do, whatever the product that is formed here, this is aldehyde, right? Just oxidize it. Oxidize the aldehyde and convert it into acid, CH3 COOH. And ketone it can't oxidize because there is no oxidizable hydrogen, so ketone will remain same. That's the only thing you have to do to identify the product of reductive ozonolysis and oxidative ozonolysis. And this is not only taking place in presence of zinc water, and it can be taking place in presence of Me2S also. Okay, so this is a summary of ozonolysis reaction. Don't lose any mark. Always I have mentioned the trick in every classes, so just follow it and get the correct answer. Can I move? Are you done with it, students? Yes. Next one is preparation of alkane. Next we will be moving into the last, that is alkyne. Alkyne, the major preparation is from, first method of preparation is in the industrial and lab scale preparation. How? By using calcium carbide on treating with water. Here Ca2 plus and this C2 2 minus. Ca2 plus and C2 2 minus. And there are two molecules of water, right? That is 2H plus and 2OH minus. Here what is going to happen? This C2 2 minus will be catching the 2 proton from here and will be forming C2H2. And the Ca2 plus ion will be combining with the 2OH minus and will be forming CaOH twice. That's the only point you had noted down. That is, by using calcium carbide I can prepare alkene. Using the calcium carbide I can prepare the alkene. Okay, not only to calcium carbide, magnesium Mg2C3. Using magnesium carbide also we can do the same reaction. How we can do the same reaction using magnesium carbide? Same, I will be adding water, and what is the product you will be getting? Same thing, C triple bond C plus HCH triple bond CH plus MgOH twice. Okay, now down to substrate in which I can convert it into alkene, that is calcium carbide and magnesium carbide in presence of water. Produce ethane. That's a point. Yeah, shall I move? That's one method of preparation of alkyne. Next method of preparation. Shall I move, everyone? Are you done, everyone? Yes. Just note down, and once you note down, just send me the reaction. Yes, everyone done, right? Yes. Next is by dehydrohalogenation of vicinal dihalide. Dehydrohalogenation means hydrogen and halogen will be removing. And we are removing it in the vicinal dihalide. Vicinal dihalide means what? yeah, there will be a halogen in the two adjacent carbon. Okay, and this is a process of removing hydrogen and halogen, and it is a step by step process. First step, what is happening? It will be reacting with alcoholic KOH. After when it reacts with the alcoholic KH, one of the halogen and the beta hydrogen, they will be one hydrogen will be removing, and we will be getting a double bond here. Okay, that is, first I have removed one hydrogen and one hydrogen in presence of alcoholic KH. Now the next step is in presence of soda amide. In presence of soda amide, NH2, sodium amide. In presence of sodium amide, what is going to happen? Again there will be removal of one hydrogen, and finally you will be getting the alkane and forming triple bond. That is a step by step process. First one is by treating with alcoholic KH, which will lead to the removal of one hydrogen and halogen. Next one is sodium amide will be giving alkyne. Okay. Yes. Shall I move to the next? Are you done? Yes. Just note down the point immediately and we can move to the next. Okay. Next one is from tetrahalides. If I am using a tetrahalides means there will be 4 halogen. If I am using 4 halogens, if I am treating it with zinc, in presence of heat, I will be getting alkane by the removal of 2ZnX. Everything is there, you just need to copy that only. And the reagent we are using zinc dust in presence of ethanol. It will convert tetrahalide to alkene. And yeah, the process is mentioned already here. Heating a vicinal tetrahalide with the zinc dust, resulting in the elimination of 2 molecules of ZnX2. So this is just a reaction only. All these things just remember only. That's the thing. Many reactions are that you have to remember. So whenever you are studying it, just compare it with another one. In the previous one where we have used zinc. Okay. Now take a comparison of both the things. That is conversion of alkene to alkane, and this is conversion of tetrahalide to alkyne. So that type of conversion you should do, and you have to study it like that. Okay. Shall I move to the next? Yes. Next one is from methane. From methane, how we can prepare? Note down the process. It is called as pyrolysis process. The process is called as pyrolysis process. What is pyrolysis? Heating methane to very high temperature, that is 1773 Kelvin temperature. I will be getting alkyne in by the release of 2H2 molecule. Heating methane to very high temperature in an electric arc, we will be getting alkyne. Yes, that's the only point you should note down. Yes. Now the last one, that is a preparation of higher alkane. How we can prepare higher alkynes? Yes. Shall I move, students? Okay. Okay. Next is synthesis of higher alkane. How I can prepare higher alkane if the question comes about higher alkane? For that, what you have to do? Ethane I will be taking. And that I will be treating it with a sodium amide. If I am treating ethane with a sodium amide, what is going to happen? The removal of hydrogen will be taken. This is a base, and here carbon is sp hybridized carbon. As it is sp hybridized carbon, this hydrogen will act as a acidic hydrogen. So there will be removal of this hydrogen, and there will be adding of Na plus into that. They will be forming a sodium salt of alkane. And this sodium salt of alkane, on treating with the alkyl halide, what you will be getting? Halogen will be, this will be having plus, this will be having minus. This minus will be attaching on this carbon, and you will be getting a higher alkane. This R is representing the higher form. You will be getting a higher alkane over here with the removal of NaX. Sodium will be combining with the halogen and will be giving NaX. That's the point. Yes. So this is all about the preparation reactions of alkyne. Now or next we can move into the properties of chemical reactions of alkyne. Okay, is it clear everyone how we can prepare higher alkane? By using sodium amide. Sodium amide is a base. It will convert it convert alkane into sodium salt of alkane, which on react with the alkyl halide we will be getting higher alkyne. Okay, shall I move to the next, students? Okay, just take a note of it. That's only, there is no much conceptual understanding in this chapter. Next is about properties of alkane. First one, this is a very important one, Kucherov reaction, addition of water. Kucherov reaction, this is a very important one. Yeah, what is going to happen? Alkyne, if I am taking alkyne, that is RCH triple bond, RC triple bond CH. I am taking alkyne, and this alkyne on treating with HgSO4 in presence of dilute H2SO4, in presence of dilute H2SO4. What is going to happen here? Addition of water is going to happen according to the Markov-Nicoff rule. According to the Markov-Nicoff rule, addition of hydrogen will be added to that carbon where there is more number of carbon, and halogen or water will be added to, or the negative part will be added to that carbon where there is lesser number of hydrogen, resulting in the formation of an enol, C double bond OH CH2. This is the enol that we are getting formed. Okay, and first step is addition of water addition by according to the Markov-Nicoff rule. And what is the next step? Next step here, enol is forming. This enol will be having a tendency to do tautomerism. As a result of the tautomerism, what is the product you are getting? According to the tautomerism step, here this double bond will be shifting towards here, and this hydrogen will be catching on this carbon, resulting in the production of a ketone here. That is, enol is there, enol is converted to a ketone. This is called as keto-enol tautomerism. Okay, and instead of this alkane, if I am taking ethane, what is the product you will be getting? This R will be replaced by a hydrogen, and the product you will be getting is an ethanol. Okay, all other alkanes will be giving ketone. All other alkanes will be giving ketone, and propane will be giving acetone, and ethane only giving acetaldehyde. This is one of the PYQ. Okay, shall I move to the next? Have you noted down? This is a very important one. All of you have to note down this one. Kucherov reaction, addition of water. Okay. Next is electrophilic addition reaction. It is addition of halogen across the three electrophilic addition reaction that I will be discussing is addition of halogen, addition of HX, and then hydrogenation reaction. Addition of halogen is added across the triple bond to form a tetrahalide. That is, if I am just adding a halogen to a, if I am adding a halogen X2, what is going to happen? We will be getting a tetrahalide. This triple bond will be breaking, and what I will be getting? We will be getting complete single bond in which there will be 4 halogen. First, this triple bond will be converted to a double bond. You will be getting a trans dihalide you will be getting. That will be again treated with X2. You will be getting a tetrahalide. That's only the point. Now, in presence of HX, how I can add HX into the alkyne? That will be following Markov-Nicoff rule. That is CH triple bond CH on treating with HCl. Hydrogen will be added to. Here both carbon are having same number of hydrogen, so I can add hydrogen and Cl anywhere, and as a result we will be getting CH2 CHCl. Now this one will again treated with HCl. That will be following Markov-Nicoff rule. Hydrogen will be added to here and Cl will be added to here, and what you will be getting? You will be getting CH3 CHCl2. This is the product. You will be getting a geminal dihalide. This is called as geminal dihalide. Yes, is it clear? Now the last one already you know, right? Hydrogenation, that is partial with the linear catalyst. C triple bond C, already we have discussed about this one. If I am treating H2 in presence of PD bar BaSO4 and in presence of sulfur or quinoline, which is the poison. What I will be getting? This will be breaking and hydrogen will be adding. What I will be getting? I will be getting a I will be getting cis alkene. I will be getting cis alkene. Now if I am using sodium or liquid NH3, if I am using sodium or liquid NH3, here also same thing going to happen. Same thing is going to happen. Hydrogen will be added, but the product is trans alkene. That's only the difference. Note down all these points. This is the complete electrophilic addition reaction of alkyne. First one, formation of tetrahalide. Second one, formation of geminal dihalide. Third one is formation of alkene by using Lindlar catalyst or Bridge reduction reagent. Sodium in presence of liquid NH3. Is it clear, everyone? Shall I move? Now the last and important one of the alkane, that is cyclic polymerization. I think this you have seen many PYQs or many mock tests. Cyclic polymerization, that is, if I am taking ethane, 3 molecule of CH triple bond CH in presence of red hot tube, what is going to happen? Cyclic polymerization will happen and which will lead to the formation of a benzene, Okay, now if I am taking, instead of ethane, if I am taking CH3 C triple bond CH, what is the product you will be getting? You will be getting a benzene, but along with the benzene, the 3 CH3 molecule will be adding in 1, 3 and 5 position. CH3, this is another product. And if I am taking 3 CH3 C triple bond C CH3, what is the product you will be getting? Red hot tube. Methyl group will be adding to all the carbon of benzene. CH3 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 H3, that is the product you will be getting. Note down these two things. Not only the formation of benzene, if I am taking extra carbon, I will be getting methyl group attached to the carbon. Okay, cyclic polymerization. Is it clear, everyone? Shall I move? Yes, this is the last part of alkane. Now one more part is there, that is benzene. Benzene I am not going to discuss much because already you know many things because of the special properties that we already discussed. Okay, let me go to the benzene. Shall I go to the benzene? Note down these 3 reactions. Once you are done with the writing these 3 reactions, I can move. Okay, shall I? Okay, everyone. Okay, next is about benzene. Benzene already we discussed in the yesterday's aromaticity part, that is, it is planar hexagonal sp2 hybridization with the bond strength is same or bond length is same, that is 139 picometer, and it is following Huckel rule, that is cyclic planar complete conjugation 4n+2 resonance energy. All these things we have discussed in the last class. Now the point that you had noted down, important point, is electrophilic substitution reaction. Electrophilic substitution reaction of benzene, that is the point, major point you have noted down here. Yeah, these are the complete electrophilic substitution reaction. First one is nitration, then halogenation, sulfonation, Friedel-Crafts alkylation, Friedel-Crafts acylation. In all these cases, the product obtaining is very easy. You can find out if you know the electrophile that is forming here. In the nitration reaction, HNO3 will be reacting with H2SO4, and the electrophile that is forming here, it is NO2 plus, and you will be getting a benzene which is substituted with the NO2. And in the case of halogenation reaction, X2 is treating with anhydrous FeCl3, or it can also treat with anhydrous AlCl3, and I will be getting a halogen substituted on the benzene. Now in the case of halogenation, you can see that the electrophile that is forming is SO3. There is no positive charge here, but still it is an electrophile because of the vacant d orbital. And the product that is obtaining here, it is not just a substitution of SO3, it is SO3H. Not direct substitution of electrophile, that is SO3 to the benzene ring, it is SO3H only substituting here. That is the mechanism of it. You will know it through the mechanism of it. Next one is Friedel-Crafts alkylation. Alkylation means RCl in presence of anhydrous Al Cl3, and here the Cl3 what it will be attaching? Yeah, alkyl group will be attaching. Remember that there is a formation of carbocation here, and as there is formation of carbocation, you should check for the rearrangement. Check for rearrangement. Okay, now the last one is Friedel-Crafts acylation. In the case of Friedel-Crafts acylation, what is the product you will be getting? You will be getting acylium ion as the electrophile, which is C double bond O R. This is the product that you will be getting. Okay, this is the complete electrophilic aromatic substitution. Is a very important one. All the time you can see a question from this part. Take a screenshot or I will be sharing it. Yeah. Now in the case of electrophilic aromatic substitution, the point that you will note down is in presence of electron donating group or in presence of plus I group, what is going to happen? The product will be ortho para directing, and in presence of deactivating group or minus group, the product will be meta directing. That is a point that I will be discussing. Are you done with this? Are you all done with this? Yes. That is ortho para directing. If I am just taking NH2 is a plus some group, right? It is a plus some group. If I am doing the nitration reaction, or what is electrophile? Concentrated HNO3 plus H2SO4. Where you can substitute the NO2? In the ortho position, para position or meta position? Which position you can substitute NO2? You can substitute NO2 in the para position as well as ortho position. That is, if it is a plus some group or activating group, the product will be ortho para. But instead of this, if I am just taking an NO2 and I am going to do the halogenation in presence of AlCl3. What is the product I will be getting here? This NO2 is a minus some group. Electron withdrawing group. Electron withdrawing group will deactivate this ring. If it is deactivate the ring, the product that we will be getting here, it is chlorine will be attaching on the meta position. Okay, among the ortho para directing, the para is going to be the major one and ortho is going to be the minor one. That is the point you have noted down. And which are the meta directing group, which are the ortho directing group, that I have mentioned in the slide. We can go through it. Okay, hope all of you understood how we can find out ortho para directing group and meta directing group. Okay, yeah. Now question can ask, among the following, which is having highest electrophilic substitution? Reactivity of electrophilic substitution. Reactivity order. I am just giving. Okay, this is NH2, this is benzene and NO2. Among these, which is having highest reactivity to the electrophilic substitution reaction? Aniline or benzene or nitrobenzene? This was one of the questions in the mock test. Yes, very good. Aniline is having the highest reactivity, then benzene, then NO2. Reactivity order. Why? Electrophilic substitution. Electrophile is a positive charge species, right? This positive charge species will substitute very easily only if the carbon is having negative charge. Negative charge will be possible only if there is an electron donating group attached. This electron donating group will push us electron towards the benzene ring and it will activate the ring, or it will increase the electron density of benzene ring. If the electron density of benzene increases, electrophile can easily attack. So the reactivity will be higher. Then comes benzene, then comes NO2. NO2 is a electron withdrawing group or it is a deactivating group. Okay, that's all the point here. And next is addition reaction of benzene. Addition reaction of benzene I have mentioned in the slide. It's a very easy thing only. First one is hydrogenation reaction. I can add hydrogen into the benzene. That is 3H2 I can add to benzene. In presence of nickel and heat, I will be getting cyclohexane. Okay, just adding 3 hydrogen in presence of nickel, I will be getting cyclohexane. That is the double bond will be broken and hydrogen will be added. Next one is chlorination in presence of UV light. Chlorination in presence of UV light, you will be getting a compound in which name is very famous, that is BHC, benzene hexachloride. Benzene hexachloride. What is this benzene hexachloride? Cl, 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 Cl. Yes. Anyone is saying something? This is benzene hexachloride, and what is the formula of it is C6H6Cl6. Because of that particular formula, it will be also called as C666 compound, and the name of this compound is gamoxane or lindane. Name of this compound is gamoxane or lindane. Next one is bridge reduction. Bridge reduction already you know, right? Double bond will be converted to the single bond. In the case of benzene, that one double bond will be broken and that will be added with the hydrogen, and you will be getting cyclohexa 1,4-diene. One of the double bond will be broken and that will be added with the hydrogen, and you will get cyclohexa 1,4-diene. So all these things, everything I have mentioned in the slide only, just need to go through the slide, and the doubtful part you can ask me if you still have doubt. Okay, and take a note of all the things that I am writing in the board, because yeah, that is what you will be missing, because these slides I will be sharing. Yeah, so this is all about the benzene and all. Now there are few questions are there. All the questions I am very sure that you can solve it easily. You can solve it. All reactions you have studied already, so you can easily able to solve it. And after this, yeah, lot of PYQs I have added it. You can solve it by yourself. Because of time limitation, I am not able to do it, but I am very sure that you can able to do it. So students, that's all about today's class, hydrocarbon. Tomorrow we'll be seeing you with the next chapter. Yeah. So thank you all for joining, and thank you for attending. Yeah, all of you can go.